The topic is solving equations, the addition and multiplication properties. The objectives in this topic are identify solutions of equations, use the addition property of equality to solve equations, use the multiplication property of equality to solve equations. So, a bit of a review. Statements like 5 plus 2 equals 7 are called equations, anything with an equal sign. An equation is the form expression equals expression. And if we labeled an equation, the equal sign would be in the middle. Then we'd have the left side and the right side. The equation is saying that these two sides are equal to each other, that they have the same value. When an equation contains a variable, deciding which values of the variable make an equation a true statement is called solving an equation for the variable. So up until now, we've just been looking and seeing, are things solutions? We haven't been asked to find the solution. And again, a solution is a value for the variable that makes the equation a true statement. So we've done things like this before. Determine whether -2 is a solution of 2y plus 1 equals -3. We would take our -2 and we would plug it in, replace y. So instead of 2y plus 1, we'd have 2 times -2 plus 1. We want to know if that's equal to -3. 2 times -2 is -4. -4 plus 1 is -3. So since -3 equals -3 is a true statement, -2 is a solution of the equation. Now solving. To solving, we have to solving. To solve, we have to use properties of equality to write simpler equations, all equivalent to the original equation, until the final equation has the form x equals number or number equals x. Equivalent equations have the same solution, and the word number above represents the solution of the original equation. This will make sense, I promise. The addition property of equality. I'm going to say it in its technical form, and then I'm going to simplify it for you. Let A, B, and C represent numbers. If A equals B, then A plus C equals B plus C, and A minus C equals B minus C. So, in other words, the same number can be added to both sides or subtracted from both sides of an equation without changing the solution of the equation. That is extremely powerful when it comes to solving. So let's take a look at x minus 4 equals 3. We want to solve this for x. Now you might be able to look at that and say, hey, 7 minus 4 is 3. X equals 7. But that's not solving. Solving is following a specific process. That process is going to be undo things to get the x by itself. And then whatever we do on one side, we have to do on the other. So here we have x minus 4. We want to get the x by itself. We need to undo minus 4. The opposite of minus is plus. So we plus 4. Whatever we do to one side, we do to the other. Plus 4 on both sides gives us x equals 7. That's how we need to get x equals 7. So again, breaking it down, to solve for x, we need to rewrite the equation in the form x equals number. To do so, we add 4 to both sides of the equation. So instead of x minus 4 equals 3, we add 4 to both sides and get x minus 4 plus 4 equals 3 plus 4. Just like an old-fashioned scale that you see justices blind holding outside of a courthouse. The two sides need to stay in balance. If we add 4 to one side, we have to add 4 to the other side. The minus 4 plus 4 on the left cancel each other out, leaving us with just x. And then on the right, 3 plus 4 gives us 7. We can always check to see if we have the right answer. To check, we replace x with 7 in the original equation. Instead of x minus 4 equals 3, we want to see if 7 minus 4 equals 3. It does. It's true. 7 is the solution. Now remember, when you're checking, you have to check in the original equation, not one of the equations that we get along the way. And we can get the variable alone on either side of the equation. X equals 3 and 3 equals x. Both of those are saying the solution is 3. So here, negative 2 equals z plus 8. The z is on the right. So this one, we're going to get number equals z. And that's okay. It doesn't have to be z equals number. They mean the same thing. To get the z by itself, we want to get rid of plus 8. We undo plus 8 with minus 8. So we need to subtract 8 from both sides. Negative 2 minus 8 equals z plus 8 minus 8. Negative 2 minus 8 is negative 10. Plus 8 minus 8, those cancel away. Number plus its opposite. So negative 10 equals z. And most of the time, we're not going to go through the steps of checking the equation, checking the solution to see if it works. The check is always left to the student in most cases. So feel free to check negative 10 in that original equation and make sure that it works. We have a multiplication property of equality. In the addition property, we were able to add or subtract the same thing from both sides without changing the value. This property tells us we could multiply or divide both sides by the same thing and not change the value. So with 4x equals 8, that's 4 times x. We need to undo times. We do that with dividing. Divide both sides by 4. 4x over 4 equals 8 over 4. 4 divided by 4 is 1. 1 times x is x. 8 divided by 4 is 2. So x equals 2. When I did this, 4 divided by 4 is 1. 1 times x is x. That's the whole point of dividing both sides by 4. We want to undo the 4 that was in front of the x. We want to just have one x, a single x. And one x is always written as just an x. Likewise, if we have just an x, we can always assume that there's an invisible 1 right in front of it. Let's check this value, take our 2, plug it into the original equation. 8 equals 8. It checks. The solution is 2. X divided by negative 4 equals 7. This time we want to undo dividing by negative 4, so we're going to multiply both sides by negative 4. The negative 4 divided by negative 4 on the left leave us with positive 1x, or just x. 7 times negative 4 is negative 28. And that is it for this topic.